A box of mass 10 kilograms lying on a rough surface is being pulled by a force of 30 newtons as shown in the diagram above. If the acceleration is 2 meters per second squared, find the coefficient of friction between the box and the surface. So of course the acceleration must be in this direction along the slope. So the weight here would be 10g, and then there'll be a normal reaction force, and of course there'll be a frictional force acting this way. There's no acceleration vertically, therefore the vertical forces must be in balance. Now let's just very quickly resolve this force. So the 30 is here, so this side is the adjacent. So this would be 30 cos 30, and this will be 30 sine 30. Sine 30, of course, is a half. So 30 sine 30 is just equal to 15. So looking at the vertical, force is up, which is R plus 15, must be equal to the forces down, which is 10g. And if I take g equal to 9.8, that means that R plus 15 is equal to 98, and then R is equal to 83 newtons. Looking horizontally, we have acceleration, so we need to use F equals ma. The resultant force would be 30 cos 30. Take away the frictional force, which is opposing the motion, and that's going to be equal to 10 times the acceleration, which is 2. So F is going to be 30 cos 30. Take away 20. So that will be 30 times cos 30. Take away 20. Gives me 5.981. Correct to 3 decimal places. Now we know in limiting friction that F is equal to mu R, therefore mu is equal to F divided by R, and R of course was 83, so mu is going to be my last answer divided by 83, which is 0.072. Correct to 3 decimal places.